Very good afternoon, students. Let us continue into the next set of properties. We have seen in the previous session properties 1 to 4. Let us look into the fifth property onwards. An example determinant delta is already kept ready for verification. And what does the property P5 say? Property P5 says that if all elements in a row or a column can be expressed as sum of two or more terms, mere numbers, two or more numbers, then the entire determinant can be split into two individual determinants. The sum of the values of the two determinants will be definitely equal to the value of the original determinant. Let us see how it works out. Nothing is expressed as sum of two terms, isn't it? The property requires all elements in a row or column to be expressed as sum of two terms or more. Okay. So, the number of terms, the number of split determinants will be equal. Now, what we shall do is, I shall take up the row 2. Row 2 contains elements 2, 1 and minus 3. I am going to express 2 as 1 plus 1. 1 I am going to express as 1 plus 0. Negative 3, let me write minus 2 minus 1, so that the total matches, and we are in a position to write all elements in row 2 as sum of two terms, and we shall split the determinant into two individual determinants and go for the verification. Before that, let me tell you what is this determinant equal to. That is 10. Students can verify, and I am continuing from the memory of the previous session. Okay, so delta is 10, but I am going to now work out the delta like this. Row 1 is 1 minus of 1, 1, no change. Third row also no change. Second row, as you can see, 2, let me write 1 plus 1, 1 let me expand as 1 plus 0, minus 3 expanded as minus 2 and minus 1. Now, the property says this determinant can be split into two separate determinants. Okay, how to do that? Students can observe. So, this delta is equal to determinants of the same order, and row 1 contains singular terms only, 1, minus 1 and 1. Third row also there is no change, 1, 1 and 1. Second row, yes, of course, all the first elements which are 1, 1 and minus 2, they will form part of first determinant 1, 1 minus 2, followed by second elements, the 1 and 0 and negative 1. Am I right? 1 and 0 followed by minus 1. They will form part of the second determinant. Let us evaluate the sum. Let us evaluate every individual determinant, verify whether the sum is same as 10. Let us go ahead. First row, first element multiplied by cofactor 1 minus of minus 2, so plus 2. Cofactor will change the sign of negative, so it is positive 1 into the cofactor 1, again minus of minus 2 plus 2. The third element is 1 multiplied by cofactor 1 minus 1. Now that completes determinant 1. Second determinant, let me write below the first determinant, probably just open a parenthesis to make a difference. Okay, first element 1. What is the cofactor? 0 minus of minus 1, so it is plus 1. Cofactor changes the sign, so it is positive 1 into the minor is 1 minus of minus 1, and thereafter the last 1 into 1 minus 0, 1 minus 0. You can see that the numbers now you can add up 3 plus 3 plus 0. From parenthesis you can see it is 1 plus 2 plus 1, and the answer is 10. And that was the anyway original answer of the undivided discriminant delta, determinant delta. So before splitting, determinant value was 10. After splitting and evaluating, the individual sums are 6 and 4, but still the total is maintained at 10. So this is what the P5 can help the students. So when it is the form of variables, let us say x plus y, y plus z, z plus x, then the students can simply write it as x, y, z in one, y, z and x in next determinant. That way you are able to make the simplification bit easier. So that is the effectiveness of property P5. The last of the properties P6. Now P6 works to be a very smart property. Irrespective of whatever you do, many row operations we can try. The property reads like this. I am not going to write it as a textual notes here. I would like to spell it out so that you can make note. Consider any row or a column. So you can find if it's a 3 by 3, 3 elements in a row are there. To this row, we add equal multiples of any other row to this row. What did I say? Consider, let us say, row 1. Okay. And consider any other row, row 2 or row 3 for example. You can multiply this with any scalar, for example 5 times, and add it to row 1, or remove it in row, remove it or subtract it from row 1. Store it in row 1 again. This row operation, for example, let me carry out this row operation, let us say to this delta. Okay, nothing happens to the value of the determinant. So that is a remarkable feature. The moment the row is changed, all elements are changed, you expect naturally completely different value of the determinant. But here it doesn't happen so. So let us use, so let the row operation be like this. Row operation be R1. In place of R1, I am going to all elements of R1 to this row. With the elements of this row, we add equal multiples. When I say equal multiples, all elements in a row are to be multiplied by the same real constant. I just selected 5, isn't it? 5 times of row 3. And when I say row 3, all elements in row 3, which is 1, 1 and 1. Let us do it. What is the element in R1? 1 minus 1, 1. 5 times of R3 is 5, 5 and 5. The resulting elements are 6, 4 and 6. So now the delta is modified. Okay. How is it modified? Row 1 elements are now 6 and 4 and 6. Second row 2, 1 minus 3. Third row 1, 1 and 1. Let us evaluate. Go ahead. First element into its cofactor. Cofactor 1 time 1 minus of minus 3. Done. Next, immediately followed by cofactor negative sign of 4 and minor 2 times 1 minus of minus 3. It is the plus 3. Followed by the last element 6 into its minor 2 minus 1. So the answer 6 times 4 minus 4 into 5 plus 6 into 1, 24 minus 20 plus 6, which is 10. So you can see nothing is changed. The original delta value 10 is recurring here, repeating here. Though you have executed a row operation, elements in row 1 are completely changed but linearly dependent on R3. The elements of R3 are multiplied by any constant, real constant, and added to the entries in row 1. Alright. Students should watch what is happening. Two things you have to keep in mind. Do not entertain multiplying entries in row 1 by another constant. That is not possible. Why not possible? Multiplying elements in a row will multiply the entire determinant. That's what we saw. Property P4. And we saw it is a common factor property. So that cannot happen. To all elements in a row, you can add multiples of any other row. Okay? Not multiply the same row with any other constant. That is prohibited. Students must avoid. Then, that explains property P6, but what will happen if I do any other operation? We can try also. Okay? To the same delta, for same delta, execute the row operation like this. R2, take R2 for example. To R2, I am going to add suitable multiples of, say, row 1. So let me take row 1. And why only add? Let me multiply with 2 and subtract. Okay? Done. So what are the elements in row 2? So the delta becomes first row is not disturbed, third row is not disturbed, first row is 1 minus 1 and a 1. But the elements in row 2 are 2, 1, minus 3. These are elements in row 2. Now, row 1 elements are multiplied by 2. So, multiplied by 2, every element multiplied by 2, 2 times of 1, 2 times of minus 1, 2 times of 1. Yeah, and I have to subtract. So, subtraction. So, let us say it involves a change of sign. And at the end I get it is 2 minus of 2, so the answer is 0. And 1 plus 2 gives 3, minus 2 minus 3 minus 2 gives minus 5. So it is 0, 3 and minus 5. Let us evaluate and see what is the result of this determinant. We are expanding by row 1, absolutely no change. So first element 1 followed by the cofactor. This 3 becomes unclear, is it? Okay, 3 times of 1 minus of minus 5. So it makes plus 5. Followed by cofactor makes it positive plus 1. And the minor is 0 minus of minus 5. And followed by plus 1 into 0 times 1 minus 3. So the answer is 8 plus 5 minus 3, that gives answer 10 again, which is the original value of delta, as you know from the beginning. Nothing has happened. So this is the efficient demonstration we have done for property 6. 2 elements in your row, you can suitably add or subtract multiples of any other row. Okay, let us do it, execute it by means of a column. So make it a column operation now. Let us take column 1. Column 1, replace it with column 1. Simply we will put C1 plus C3. Okay. When I say multiply, why always select a different multiplier other than 1? Let me take the multiplier as 1. Now, delta. I have not made changes in C2 and C3. So, C3 is 1 minus 3 and 1. And what about C2? Minus 1, 1 and 1. Column 1 has elements 1, 2 and a 1. So I am writing 1, 2 and a 1. And column 3 contains 1, minus 3 and 1. And we are going to add. So add it. Write the result here. 2 minus 3, 1 plus 1. So the column 1 has changed. It becomes 2 minus 1 and 2. Now try to expand. Follow expansion by row 1. The students are free to expand by any method. There are 3 rows, 3 columns, 6 ways to expand. Okay, I am expanding by row 1. So 2 followed by cofactor 1 minus of minus 3 plus 1 into cofactor minus 1 and plus 3 into 2, that gives positive minus of minus plus 6. Continue, plus 1 into minus 1 minus 2. So it becomes 2 into 4 plus 6 minus 1, that is 5, and minus 1 minus 2 gives minus 3. So 13 minus 3, so once again it is 10, which was the value right from the beginning, no change. So this is what demonstrates the property P6. 2 elements in a row or column, you can add suitable multiples of any row or column. The value of the determinant doesn't change. Okay. How this applies while proving of the identities given by NCERT, or let us say the past CBSE board examination questions, we will see in the following videos. Thank you.